Hey everybody. So today we're getting into 9.5 part 1. 9.5 deals with trapezoids and kites. Okay, today for part 1 we're going to be focusing on just the trapezoids, and then in part 2, our next lesson, we're going to get into kites. Okay, so go ahead and get this title here and get the definition and a picture of a trapezoid, and then we'll get into it. Okay, so trapezoids, that's the focus of our lesson. What is a trapezoid? Here's what it says. A trapezoid is a quadrilateral, okay, so it has 4 sides with exactly one pair of parallel sides, okay? The parallel sides are the bases. Okay, so here's the big thing I want to point out. Since a trapezoid only has one pair of parallel sides, okay, it is not considered a parallelogram, okay? Because if you guys remember, a parallelogram had both pairs of opposite sides parallel. Okay, this just has one pair of opposite sides parallel. Okay, so those rules that we learned for parallelograms do not apply to trapezoids. Okay, so that's the first thing to realize. Those rules don't apply. Okay, when it comes to the parts of a trapezoid, those parallel sides are the bases of the trapezoid, and then the other side lengths, the other 2 sides are considered the legs of the trapezoid. Okay, this lesson focuses on a particular type of trapezoid, and that's what the next slide is going to get into, and that's called an isosceles trapezoid. Okay, so go ahead, take a minute and copy what an isosceles trapezoid is. Okay, so here's what it says. If the legs of a trapezoid are congruent, then the trapezoid is an isosceles trapezoid. Okay, so if the legs are congruent, over on our picture here, we can see these 2 side lengths that are the legs are congruent. Okay, and that's why this thing is considered isosceles. All right, and like I said before, isosceles trapezoids, that's kind of the focus of this lesson here. All right, and we get some rules when we have isosceles trapezoids, and that's our next slide. Okay, so we actually have 3 rules here. One of them's cut off, so I'm gonna have you guys first copy these top 2, and then we'll get to that 3rd one. So take a minute and copy these. Okay, so let's just dig into them. The first one says if a trapezoid is isosceles, okay, so if we have those congruent legs, then each pair of base angles is congruent. Okay, base angles. Okay, so let's make some sense out of that. Okay, on this isosceles trapezoid right here, that's one of our bases. Okay, and base angles are the angles that touch the base. Okay, so these 2 angles, angle B and angle C, would be congruent to one another. Okay, and it's the same idea for these base angles down on the bottom as well. These 2 angles that touch the same base would also be congruent to one another. Okay, and the other thing I want to point out is that these 2 angles that touch the legs of our isosceles trapezoid are supplementary. They add to 180. Okay, so one thing I kind of want you to realize is that notice that opposite angles are not congruent. Okay, remember that was a rule for parallelograms, and that is not the case for isosceles trapezoids. Okay, opposite angles are not congruent. It's these base angles that are congruent. Same thing down here. Okay. All right, so the next one says if a trapezoid has a pair of congruent base angles, okay, so if we have base angles that are congruent, then it is an isosceles trapezoid. Okay, so this is kind of looking at this first rule kind of from the opposite direction. Okay, so if we have congruent base angles, then we can say, yeah, we have an isosceles trapezoid. These legs are congruent. Okay, so it's just kind of a way to think about it. It kind of works forwards and backwards. If we have an isosceles trapezoid, we have congruent base angles. If we have congruent base angles, we have an isosceles trapezoid. Okay, so these are just the converse of one another. All right, so the last little rule here, go ahead and take a minute and copy this, and then we'll look into it. Okay, so our last rule says a trapezoid is isosceles if and only if the diagonals are congruent. All right, diagonals are congruent. Okay, and you guys remember diagonals. We saw these, when we were dealing with parallelograms, when we were dealing with rhombuses and rectangles and squares. Okay, the diagonals are these lines that go across the shape. So that BD would be one of my diagonals, and then CA would be another diagonal. Okay, and what this is telling me is that the lengths of these diagonals are the same. Okay, the length of BD is equal to the length of CA. Okay, so there are some of our rules for isosceles trapezoids. So now that we know them, let's use them. Okay, so this first example, go ahead and copy this one here, and we're going to do it together. All right, so this is asking us a couple things. It wants us to find angle E and then segment EG. Okay, so let's first let's focus on angle E. First things first, angle E, that's this angle right here. Okay, here's what I notice. We have angle G. Okay, angle G is 137 degrees. Here's the first thing I just want to remind you of. These are opposite angles, but since this thing is not a parallelogram, these are not congruent. Angle E is not 137 degrees. But we can work our way over to it, because here's what we know. We know that these base angles, let me just highlight it, this angle G and this angle H, since they're base angles, they're congruent. All right, so let's go ahead and just first point out angle H is also 137 degrees. Okay, here's the next thing we know. These angles that are both touching the same leg are supplementary. They add to 180 degrees. Okay, so just like we always do, if I want to find this missing angle, I can just subtract this guy from 180. So if you want to show yourself in your notes, that's what we're doing. 180 minus 137. Let me do that with my calculator. Looks like we're getting 43. Okay, so there is the measure of our missing angle. And let's just go ahead and point out angle E equals 43 degrees. Okay, so a lot of the same math that we used in the previous sections, but we just kind of have to realize the small differences with how we go about finding these angles. Okay, and by the way, if we wanted to find angle F, that would also be 43 degrees, right? These base angles would also be congruent. Okay, but the other thing they want us to find is EG. So let me erase all of this stuff. Actually, hold up. Let me see if I can do this real quick, just to clean it up a little bit. Okay, so let's point out EG is this segment right here, going from E to G. All right, so it's one of my diagonals. Okay, here's what I notice. My other diagonal is 10 inches long. Okay, well, if we remember our rule, we know that the diagonals are congruent. Okay, if this thing is 10 inches long, we know our diagonal is also 10 inches long. So there it is, our other answer. Segment EG equals 10 inches. Okay, so yeah, really simple stuff. Just remember the rules. Okay, let's keep moving. Okay, so here's the next big thing that this lesson deals with, and that's called the mid-segment theorem of trapezoids. Okay, go ahead and copy this, get this formula here, put a box around it because this is an important one. Okay, so here's the mid-segment theorem. All right, I guess real quick, before we get into it, what is the mid-segment of a trapezoid? Okay, well, we know we talked in the past about mid-segments of triangles. If you guys remember, a mid-segment went from the midpoint of one side to the midpoint of another. This would be considered a mid-segment of a triangle. It's the same idea with trapezoids. Okay, a mid-segment is a line that touches the midpoint of one side and the midpoint of another side. Okay, so right there, this is considered a mid-segment. All right, and just again, I want to point out, since this is a midpoint, that means these are congruent, these pieces are congruent, something to always keep in mind. Okay, but here's what we know about the length of this mid-segment. The length of the mid-segment equals 1/2 the length of the two bases added together. Okay, so just to point out, this base right here and this base right here, if I were to add those together and take 1/2 of it, I would have the length of my mid-segment. Okay, so that's the idea with these. Let's take a look at an easy example that we can probably do in our head, and then we'll look at some that actually require us to use the formula. Okay, so on this next slide, go ahead and take a second and copy this thing, and we're going to find the measure of MN. Okay, so this one real quick, I want you to just kind of try in your head. Okay, if my two bases, they're giving us the length of both bases. If this one is 12 inches and this one is 28 inches, what is the length of MN? Okay, see if you can do it in your head using the formula we just saw on the last slide. Okay, well, here's what I know about this mid-segment. I know the length of this mid-segment equals 1/2 the length of the two bases added together. Okay, well, I can probably do this in my head. I know that 12 plus 28 would give me 40. And if those add up to 40, I know my mid-segment is half of that, 20. Okay, and there's my answer. All right, if you wanted to show yourself in your notes what we did, well, basically we plug these into our formula. Okay, this formula right here, and this is, the math that we did in our head. We said, okay, mn equals 1/2 of our two bases added together, 12 plus 28. Okay, we added those together. We took 1/2 of it, and we got 20. Okay, so what I want to point out is, some of these you might be able to do in your head if they give you easy values. They don't always give you easy values. And when that happens, we have to use our formula. Okay, so let's see an example that does that. Okay, take a second, copy this new trapezoid, and we'll solve for x. Okay, so we have weirder values. This would be more difficult to do in our head. If I just said, what's x? Okay, that's difficult. We need to actually use our formula here. Okay, so again, I'm just going to kind of highlight the pieces here. Here are my bases. Let me make them blue. Okay, so here's my base, here's my other base, and here's my mid segment. And I actually have values for all three of those things. Okay, so on this real quick, let's write out our formula real quick. Let's remind ourselves. By the way, in our formula, we kind of use this MN as the generic name of a mid segment. That's not always the name of your mid segment. On this one, the name of my mid segment is KL, right? So yeah, let's just plug our numbers in. Okay, here's what we know. Our mid segment, 23, equals 1/2 of our two bases added together. Okay, one of our bases is a 4x minus 1. By the way, I'm going to start with the 4x minus 1. It doesn't matter which one you start with. Okay, and then plus the other base, 15. Okay, and I just want to point out, I could have written this as 15 plus 4x minus 1, but I like writing it this way better. Okay, so now we have an equation. We can solve this thing. Just a little reminder, when we have parentheses, we have to deal with the math inside of the parentheses first. Okay, so let's simplify this a little bit. So we got 23 equals 1/2. Okay, inside the parentheses, there's no other, x's, so that 4x stays 4x. But we have a -1 plus 15, or 15 minus 1 gives me 14. All right, so here's something I want to remind you guys of. We actually have options with how we go from here. Here's option number 1. We can distribute the 1/2 into the parentheses. Okay, and I'm looking at my problem. These are both even numbers. That's gonna work out nicely. I'm gonna get rid of my fraction that way. Okay, here's another option though. I could also get rid of my fraction by multiplying by the reciprocal, like we've done in the past. I could multiply both sides by a 2/1 and get rid of my fraction that way. It's completely up to you. Okay, just for the sake of it, I'm going to do the reciprocal thing because it's kind of the surefire way of getting rid of the fraction. Okay, so I'm going to multiply both sides by a 2/1, which again is just a 2. Okay, so over on the left here, 2 times 23 is going to give me 46. Over here, this all just turns into an invisible 1. It disappears. They basically cancel out. If you want to cross them out, you can. And I'm left with a 4x plus 14. Okay, from here, we're just solving for x. So first thing, I'm going to subtract 14 from both sides. Okay, looks like I'm getting what? 32 equals 4x. Okay, last thing, getting rid of 4, dividing both sides. Okay, and let's see, 4 goes into 32 8 times, right? So it looks like I'm getting x equals 8. I'm going to go ahead and flip it around. Okay, just real quick, is that what they asked me for to solve for x? Yeah. Okay, so we're done on this one. All right. But again, the big thing is plugging your parts into the formula correctly. Make sure you always start with the mid segment. Okay, I just want to point out, sometimes your variable is going to be in your mid segment. Sometimes your variable is going to be in this spot and not necessarily in the parentheses. Okay, so just be careful. All right, so yeah, I'm going to have you guys go ahead, try one of these on your own. Go ahead and draw this new trapezoid and write out your equation, solve for x. Give it a try. Okay, so again, I want to point out the parts. Here are my bases of my trapezoid. Here is the mid segment. All right, so now I can go ahead and plug these into my formula. I just want to remind you guys real quick, here's the formula. The mid-segment equals 1/2 of the two bases added together. Okay, so let's start with our mid-segment. On this one, it's the 3x plus 2. Okay, so I know that mid-segment equals 1/2 of my two bases added together. One of the bases is 15, one of them is 25. Okay, so what's happening on this problem is kind of what I warned you of on the last one. My variable did not end up in the parentheses. It was part of the mid-segment, so it ended up over here. Okay, just make sure you get your parts in the right spot. Don't worry about where the variable lands. Just worry about getting your parts in the right spot. Okay, so but I do have some simplifying I can do here. So I got a 3x plus 2 equals 1/2. 15 plus 25. Looks like I'm going to get a 40 inside of this thing. Okay, so I just want to point out, I could get rid of this 1/2 by multiplying by the reciprocal by a 2/1. Okay, and I just want to point out one small thing. If I were to do that, I would make sure that this 2/1 over here was multiplied by both the 3x and the 2. Okay, but I think it's easier to just distribute the 1/2. Okay, I can do that really quickly. Taking 1/2 of 40, I know I'm just getting a 20 on the right-hand side. Okay, so instead of doing the reciprocal thing, I'm choosing just to take 1/2 of the parentheses. Okay, so yeah, that means I have a 3x plus 2. Okay, no matter which way you do it, you're going to get the same answer though. Okay, now I'm going to go ahead and solve here. So first, we'll subtract 2 from both sides. 3x equals 18. Divide both sides by 3. 3 goes into 18 6 times, so x equals 6. Okay, cool guys. So yeah, that's the idea with the trapezoids. Nothing too crazy. Just remember to use your mid-segment formula when you get these weird values. Okay, so yeah, that's it guys. I'll see you in class. Bye.